Hello students, welcome to the C language training program. Today I want to discuss about queue data structure in C programming language. How to create the queue data structure in C programming language. Now the last session I discussed the stack data structure. What is meant by stack? Stack is nothing but last in first out data structure. What is mean by stack? It is a linear list. Store the elements last in first out manner. What is mean by last in first out manner? Which element is last inserted, that should be removed first. Which element is first inserted, that to be removed last. Which are the real life example for the stack? Pile of plates on the dining table. On the dining table, first I place the plates, top of each other second plate, top of each other third plate. If I place the first plate, that should be removed last. Which plate is last inserted, that should be removed first. Which plate is first inserted, that should be removed last. Which is the real life example for the stack? Pile of plates on the dining table. Last in first out manner. Which element is last inserted, that should be removed first. Which element is first inserted, that should be removed last. Which are the stack operations? Push, pop, display. Push is nothing but insert an element into the stack. If you want to insert the new element into the stack, it is called as push. What is meant by pop? If I want to remove the element from the stack, the deletion element from the stack is called as pop. What is meant by display? Whatever stack you are already created, the list of elements to be displayed. Top to bottom, all elements to be displayed. Whenever push function is possible, if the top indicator less than or equal to size minus 1, push is possible. If the top is less than or equal to size minus 1, you can insert the elements. Whenever top is greater than size minus 1, push function not possible. It is shown the error stack is overflow or stack is full. Whenever pop operation is possible, if you delete element from the list, that is pop. If the top equal to minus 1, stack is empty. Top equal to minus 1 called as stack is empty, there is no elements, you can't remove. If the top is greater than or equal to size minus 1 or top is greater than or equal to 0, whenever top is greater than or equal to 0, you can pop the elements. If the top equal to minus 1, there is no element, stack is empty. It is called as underflow. When you display the stack elements, if you have at least one element or more than one element, then only you can display. If the top equal to minus 1, stack is empty, there is no display. Finally, what are the functions can be used? Push, pop, display functions. What is the drawback of the stack? Drawback of the stack, anywhere you can't insert the elements, anywhere you can't delete the elements, top position only to insert the elements, top position only to delete the elements. At topmost only to insert elements, at the topmost only you delete the elements. What is one more kind of data structure in C programming language? Queue data structure you have, queue. What is meant by queue data structure? FIFO manner, first in, first out. Which element is first inserted, that should be removed first. Order wise, first element will be first remove, second element is second remove, third element is third remove. It is a queue manner. Whenever some persons are standing on the queue, any tickets counter, some persons are standing on the queue, the first person taken the first ticket and quit from the queue. Second person taken the second ticket and quit from the queue. Which person is last stander, that person taken the last ticket and quit from the queue. What is the operation of the queue here? First in, first out manner. Which element is first inserted, that should be removed first. Which element is last inserted, that should be removed last. Suppose my queue size is 5 elements. I can insert 5 elements. Suppose if I want to insert the new element into the queue, wherever insertion possible, back. What is meant by back here? Rear index. Every queue can perform with 2 indexes. One is for front, another one rear. Front is nothing but which is the first position element, that is front. Front index is 0. What is meant by rear? Which is the last element in your queue, that element is called as rear index. Front equal to 0 index, rear equal to size minus 1. If my queue size is 5, 0 to 4. 0 is the front index, 5 minus 1, 4 is the rear index. If you want to insert the new element into the queue, where you can insert the new element? Rear position you can insert the elements. The new element inserted at rear. If I want to delete the element from the queue, front position to delete. Deletion at the front, insertion at the rear. Whenever you are insert the new elements into the queue, which to be increment? Rear plus plus. If you are insert the element into the queue, rear index increments, rear plus plus. If you are delete the elements from the queue, which index to be increment? Front plus plus. If you remove the elements from the queue, front plus plus, front index to be increment. If you insert the elements into the queue, rear plus plus, rear position increments. Finally, what is my conclusion? The queue is a data structure. It is a linear data structure. Queue is also linear data structure, line by line to store the elements. Line by line to store the elements. It is a FIFO manner, first in first out. Which element is first inserted in your queue, that should be removed first. Which element is last inserted into the queue, that should be removed last. Stack is a LIFO manner, last in first out. Which element last inserted, that to be removed first. But the queue is a FIFO manner. What is the way you are inserted? Same way to delete. Stack, which is the way you are inserted, reverse way to remove the elements. But the queue is which is the way you are inserted, same way to remove the elements. What are the queue functions you have? Insertion, deletion, display. Stack also function, push, pop, display. Queue is also you have the 3 major operations or 3 major functions: insertion, deletion, display. What is meant by insertion? If I want to add the element into the queue, which queue is already there, if I want to add the new element into the queue, that is called as insertion. Insertion positioned at rear. Which element I want to remove from the queue, it is called as deletion. The deletion at front. Insertion time rear plus plus, deletion time front plus plus. One more function you have, display. How to display the queue elements? Front is equal to 0, rear equal to size minus 1. Front to rear, all elements to be displayed one by one, front to rear. Whenever insertion not possible into the queue, if rear reach to the rear is equal to size minus 1. Whenever rear is equal to size minus 1, queue is full. Whenever rear is less than or equal to size minus 1, you can insert the elements. Whenever rear reaches to the size minus 1, queue is full. Whenever deletion not possible, if the front equal to rear equal to minus 1. What is meant by front equal to rear equal to minus 1? Initially for the queue there is no elements. Whenever the queue no elements, there is no deletion. Front equal to rear equal to minus 1 called as, it's empty, queue is empty, there is no elements, you can't delete. Whenever deletion is possible, if the front equal to rear equal to greater than or equal to 0, less than or equal to size minus 1, greater than or equal to 0, you can remove the elements. Whenever display function possible for the queue, if the front or rear 0 or above 0 index, at least one element or full elements, then only you can display. If the queue you have the at least one element or full elements, then only display. If the queue there is no elements, there is no chance of display. You can't display the elements because the queue is empty, underflow. Now, every queue, what is the problem? Every queue, insertion at rear, deletion at front. Again, what is the drawback of the queue? It is a linear queue. Linear queue drawback, insertion at rear, deletion at front. Anywhere insertion, anywhere deletion not possible. Anywhere you can't insert the elements, anywhere you can't delete the elements. Stack is only one end you have. Top only insert, top only delete. But the queue you have two indicators, two ends, front, rear, front, back. What is a real life example for the queue? Everywhere queue follows. If you want to move the car, within the queue only cars will be there. First car will be moved. After that second car will be moved. Queue on the queue. Whenever the cars are in the queue now, first car will be first quit, second car will be second. Tickets counter also standing the person's queue wise. Which person first standing, that should be take the first ticket and from quit from the queue. Which person is last standing, that should be take the last ticket and quit from the queue. What is the drawback of the queue operations? Insertion, deletion not possible anywhere because it is a linear list data structure. Finally, what is the definition of queue? Queue called as linear list. Queue is similar to array, list of elements, FIFO manner. It is a process of FIFO, first in, first out. What are the queue functions we have? Insertion, deletion, display. Queue can be implemented with arrays, queue can be implemented with pointers, queue can be implemented with linked list. Queue can be implemented with array, array means fixed size. Queue can be implemented with pointers, dynamically use. Queue can be applied with linked list, list of elements, link of elements. You see that now while working of queue, what are the definitions will be move on to the queue. Queue is nothing but abstract data structure. Queue is nothing but abstract data structure. It is similar to stack. But unlike stacks, a queue is open at both ends. Stack will be only one end will be there. One end is closed, one end only open. But the queue is open at both ends, front, rear. One end always to insert data, one end to be insert the data, that insertion called as NQ function. In the stack, insertion called as push function. In the stack, insertion called as push, but in the queue, insertion called as NQ. In the stack, deletion called as pop, but in the queue, deletion, removing called as DQ, deleted queue. Now, for the queue, one end for insertion, another end for deletion. But in the stack, same end insertion, same end deletion, top only insert, top only delete. Queue insertion called as NQ, queue deletion called as DQ. Now, the queue will be follows which manner? First in, first out. Which element is first inserted, that should be removed first. That will be accessed first. In the real world example, queue can be like anywhere, single line or one way. Whenever you take on the road one way, you have all vehicles are one by one enter the and one by one exits. Whenever you have the one way route, which vehicles are first enter, that should be first exit. Which vehicle is last entered, that will be exit last. It is a FIFO manner. In the real life example, many you can take the queues, tickets window, ticket counter or ticket window. At bus stops also, it is followed by queue mechanism. Now, if you understand this queue, you have the both ends, two different ends will be there. It is open, two different ends will be there. You see that whenever you are working with a queue, what is the diagram can be understand for the queue? Check it. The queue is it's a vertically data structure. You have vertically represent. Stack is horizontally it will be there, but the queue is it's vertically you can represent. Now suppose this is my queue. This is the diagram can be implement for queue. Suppose my queue name Q, my queue name is Q of 5. Q of 5 means 5 elements. Every queue two indicators, I mean 2 indexes you have. First index you called as front. The first index is called as front index, front. It's called as front equal to 0. The last index, I mean rear index, back. Rear equal to size minus 1, rear is 4. Initially there is no elements on the queue at the time. What is my statement? Initialize front equal to rear equal to minus 1. Front equal to rear equal to minus 1. It's called as, whenever I indicate this front equal to rear equal to minus 1, it is called as front equal to rear equal to minus 1. That is called as queue initialization. Front equal to rear equal to minus 1. It is called as empty. Currently the queue is empty, there is no elements. Every queue one by one to insert the elements. Suppose first I am inserting 10, suppose next I am inserting 20, suppose next I am inserting 30, next I am inserting 40, the queue elements one by one insert. When I remove these, first 10 will be removed. In this queue, if I want to remove the elements, which will be removed first? 10 elements. Which element is first inserted, that should be removed. Whenever I remove this, the front will be moving this position. Front is moving to next, front plus plus. If I remove that, again moving on that next, front is moving on this. If I remove that, next I want to, front is moving on this position. If I remove that, front is moving on the next position. If I remove that all elements, the front and rear equal to minus 1. Whenever all elements are removed, front and rear equal to again minus 1. Whenever insertion time, if I want to insert elements, this is deletion operation. If I want to insert element, how it is inserting now? First 10 inserted, first 10 inserted. Whenever I inserted the 10, front, rear both are same position. At the time here rear is not available, because in my list only one element I inserted. At that time, whenever the queue only one element I inserted, at that time front, rear same position, front, rear 0 only. After insert this element, second element, when I insert the second element, at that time which index will be move on? Rear. Rear index will be move on. Now rear plus plus. After that, if I insert the 30, insertion at 30, at that time again rear index will be increments. It is moving on rear index will be increments. If I insert the next element, again the rear index will be increments. If I insert the next element, again the rear index will be increments. Every time rear will be move on. Insertion time rear will be move on, deletion time front will be move on. Now you see this is also for rear will be move increments. Insertion time, if I insertion that, at that time which will be move on? Rear plus plus. If I want to delete the elements, which will be move on? Front plus plus. One is for front plus plus, another one rear plus plus. Whenever front equal to rear equal to minus 1, queue called as empty. This is the operation first in first out manner to make a queue, front and rear. Now see that while working of the queue here, which are the basic operations I discussed? See, NQ will be there. What is meant by NQ function now? If I want to insert an element into the queue, is called as NQ. If I want to add the item into the queue, called as NQ. Next one is DQ, you have deletion queue. If I want to remove the element from the queue, is called as DQ, deleted queue. A few more functions required to make above mentioned Q operations, NQ and DQ. Peak function is required. What is meant by peak function? Which is the very beginning element, that is called as front in your Q, which is the front element, very beginning element without removing it, that is called as peak. Peak is called as front element in your Q. Is full function. What is meant by is full function? Whenever Q reaches to the size minus 1, rare reaches to the size minus 1, Q is full. Actually my Q size is 5. My Q size is 5. Initially rare is 0. After insertion rare is 1. After that rare is 2. Rare is 3. Rare is 4. Whenever rare is reaching to size minus 1, there is no insertion. Insertion not possible. At that time is full. One more is there, is empty. Whenever is empty, check if the Q is empty or not. Whenever I delete the 1 by 1 elements, first 10 deleted, next 20 deleted, next 30, next 40, next 50. Whenever all elements are deleted, there is no deletion function. Whenever front and rear equal to minus 1, there is no deletion. If the Q is empty, there is no deletion. If the Q at least one element or full elements. If the Q at least one element or full elements, we can remove. If the Q is empty, there is no deletion. That is called as is empty function. Now we always DQ pointed by the front pointer. Every deletion is front position, and if you want to insert the elements, every time always NQ. It is called as which pointer? Rear. DQ function working with the front. DQ function working with the front pointer. NQ function working with the rear pointer. Back of the Q. You see that if I want to work with the program of this Q operation program, check it. stdio.h standard input output header file. String.h, strings can be done, string length, string lower upper. stdlib.h standard library, and std boolean type also use, boolean functions. Hash define max 6, size of your Q. Hash define is macro, size with 6. Int array, Q array, size is 6, Q array. Initially front is 0, rear equal to minus 1. Initially front I assign with 0, rear equal to minus 1. Item count equal to 0. I mean how many items I have. What is my first function? Peak function. Peak. Whenever the Q will be display as peak, in your Q first element called as peak. In your Q front element called as peak. Initial element called as front element called as peak. Return the front. Return the front. Int array called as array. Return the front. Whenever boolean is empty function is empty, whenever Q is empty, item count is 0, there is no elements. Whenever return boolean is full, item count equal to max or max minus 1. Whenever the Q position item count is 0, there is no elements. Whenever the item count is maximum size, Q is full, boolean type. I want to find out size of my Q, return the item count. Suppose my Q have the 5 elements, what is my size? 5. If my Q has the 10 elements, what is my item count? Return 10. What is the logic of insertion? Insertion, how to run of that? Insert, void insert, data, I mean element to be insert. Insert function, insertion, NQ, data to be insert. Whenever insertion is not possible, whenever insertion is possible, not is full. If the Q is not full, insertion possible. If the Q is not full, insertion possible. Rear reaches to max minus 1. If the Q is full, at the time insertion not possible, not full. Whenever rear equal to max minus 1, rear assigned to the minus 1, I mean empty. Int array, plus plus rare, I mean rare increments, pre-increment. First increment the index rare, then store the element. Data means element. What is the logic here? Rare equal to max minus 1, rare equal to minus 1. Max minus 1 means you are reaching at last element, rare assigned to the minus 1. If it is not pre-increment, rare should be increment index, then store elements. Item count plus plus. How many elements you can count? Remove data. Whenever remove the element, deletion, front element to be removed first. After that front increments, next element is moving on front. First element remove, then moving on next, second element removing, then moving on next. Whenever front reach to the max size or max minus 1, front 0. Whenever front reach to the max, all elements removed, front initialize 0. Item count minus minus, I mean totally how many elements are there? Item count minus minus. If I remove that, count value decrements. If I insert that, item count increments. Return the data, return type. Now you see here, insert 5 items, insert 3, insert 5, 3, 5, 9, 1, 12, order wise inserted, order wise inserted. Now front is 0, rear is 4, because 5 items. Now this is for 0, 1, 2, 3, 4, this is 3, 5, 9, 1, 12. If I insert 15, where it is inserted now? After 12. Whenever queue is full, what is the message? Queue is full. If I want to remove one item, first element remove. Which element is removed? 3. Front position element is removed now. At that time, 3 will be removed. Now rear is at 5. Now here, this is the front, this is the rear. If I want to insert 16, after 15 it is inserted now 16. After 15, whenever queue is full, element will not be inserted. 17, 18, like that also I can insert. At that time it is shown the error, because you are already inserted the element. I want to print which is the front. Peak. Peak is nothing but front element return. Whenever queue is not empty, then I want to remove the data. Queue is not empty, then remove. This is basically queue operation, queue functions we have. You see that now while working of queue, now here insertion NQ, deletion DQ, and display, these are the major function. Suppose you see that if I go for the queue, it's a linear list, the display the elements order wise you can display the elements. Suppose my queue size is 4 size, it's a vertically you can arrange the data. My queue is my array name, queue of 4. Initially front and rear I used with -1, it's called as is empty, initialize. After that I want to go for function. What is my first function I want to use? NQ function. NQ means insertion, insert the elements. Suppose I want to insert 10 elements. In my queue I want to insert 10 elements. Now the initially queue is no elements, I want to insert the 10 elements. How to insert of that 10 elements? Now here I want to insert. Now I want to insert these queue elements to be insert one by one. First I want to insert with 10. Under queue I want to insert the 10 elements. That is inserted at the front position. Now 10 it is inserted. After insert that front equal to 0, at that time rear position also 0. Front is 0, rear is 0. Now I want to insert at 11. I want to insert at 11. 11 I want to insert. When I want to insert the 11, at that time also the next position, I mean rear increments. Rear will be increments. Here every insertion time which to be used? Plus rear increments, pre-increments. Now here 10 inserted, after that 20 inserted. Now this is front position, now this is front, now which will be moving on? Rear will be moving on. Now here rear will be moving, rear will be increments. Now here front rear previously this position, now front rear this position, now it is increments, rear will be moving on this location, rear increments. How it is increment of this here, plus plus rear. After that I want to insert the next element now. What is my next element I want to insert here? Suppose I want to insert 30 element, next is 30 element I want to insert, 30 I want to insert. At that time then you have to use with next element insert 12, I want to insert 12. At that time also rear will be moving. Now here rear will be moving here, rear increments. Which element is inserted here? Here I inserted with 12, here I inserted 12, previously not 20, na? I changed the elements. Now here this element is, now here this element is 11, second element I inserted 11, 11 I inserted, this is 11. After that third element is 12, 12 element I inserted, second element is 11, third element is 12, that position I insert the elements. Order wise it is insert the elements, rear will be moving. Now I want to insert that next element I have, I want to insert the last element, fourth element. I want to insert that fourth element, this is my fourth Q position index I want to use. Fourth element I want to insert. Now I want to insert that next element now, here I want to insert, this position to insert. Which element I want to insert now? 13, 13 I want to insert, insert 13. Now the rear will be moving on, here 13 will be inserted. Now I want to insert next 14, but that is not possible because 13 is reached to the rear maximum size. Here front rear is 0, here rear is 1, here rear is 2, here rear is 3. Whenever rear is equal to size minus 1, stop there. If what is my condition? Rear equal to size minus 1. Whenever rear equal to size minus 1, which message to be print? Q is full. Q is full, there is no insertion, Q is full. Else if it is not, plus plus rear, rear increments. Here I want to insert Q of index, Q of index position equal to what to be used, or here I used a Q of rear, rear index equal to element or data. Now this is the logic of insertion logic. Whenever Q equal to size minus 1, Q is full, rear equal to size minus 1, Q is full. Else pre-increment, rear pre-increment, rear position index data. This is the logic of insertion, NQ function logic. If I want to go for deletion, if I want to work with the deletion of this, how to delete of that Q elements? DQ function. I want to go for deletion now, DQ function to be used. Currently I have the 4 elements in this Q. What is my Q? Q of 4 size. Already I inserted some elements 10, 11, 12, previously I inserted 12 and 13. What is my front position here? This is front. Front is at 10, rear is at 13. Now I want to go for next function DQ, deletion Q. DQ called as deletion Q. How to delete that? I want to delete 10. I want to delete at 10. That means what? And in your Q 10 element will be deletes. In your Q, which is the first element, that is first deletes. Q means order wise, which element first inserted, that will be delete. I want to delete at 10. When I delete the 10, front is moving on this side, front moving, front increments. Deletion time front plus plus, front only increments. Insertion time rear plus plus, deletion time front plus plus. Now I want to insert that next, next I want to delete that again. I want to delete that next element 11, 11 I want to delete. Now I want to delete this 11. In this position I want to delete the 11 now here, delete 11, second element to be delete. Previously front is at moving at 11, now 11 also deleted, that is moving at 12. Now this is 10 is deleted, then 11 is deleted. Now the here front is moving. Next I want to delete at next element I want to delete. Next element I want to delete the 12 element I want to delete. I want to delete at 12. Now here I want to delete at 12. 12 element I want to delete. Previously I inserted with 11, but here 12 I want to delete. When I deleted the 12, now here I want to delete this. This I want to delete. This position to delete the element. 12 is deleted. Whenever 12 is deleted and this is moving, front is moving, every time front only increments, front plus plus, every time front only increments, front plus plus, front index only increments. Now I want to delete at 13, the last one, I want to delete at 13, last element I want to delete. Now I want to delete at last element. At the time all elements I deleted here. Whenever I deleted with all elements, when I deleted with all elements, I want to delete at 13. At that time all elements are deleted here. At that time what happened? Front rear equal to minus 1, all elements deleted. At that time front rear should be assigned to the minus 1. Whenever all elements are deleted, what is the function logic here? If front equal to rear equal to minus 1, front equal to rear equal to minus 1, printf. What is the message? Q is empty, there is no deletion because all elements are deleted. Otherwise you want to delete that data equal to Q of which index to be deleted? Rear, not rear, front index element to be deleted. Front index element to be deleted. Front plus plus, front index increment. This is the logic. Whenever front equal to rear equal to minus 1, Q is empty. Data equal to Q of front increments. If I want to display the elements, front equal to rear equal to minus 1, there is no display. Whenever front is greater than 0, rear is less than minus 1, display possible. This is called as DQ function, deletion to be processed. Finally, what are the data structure? Q data structure I discussed. Now the Q data structure similar to stack. Stack is a LIFO manner, last in first out. Q is a FIFO manner, first in first out. Which element is first inserted, that should be removed first. Which element is last inserted, that should be removed last. Q insertion called as NQ function, Q deletion called as DQ function. Insertion possible at a front, insertion possible at a rear plus plus, deletion possible at a front. Which element is first inserted, that should be delete first. Front moving, based on front only to delete. Insertion is at rear plus plus, rear increments. Whenever front equal to rear equal to minus 1, no deletion. Whenever rear is equal to size minus 1, whenever rear equal to size minus 1, Q is full, there is no insertion. If the front equal to rear equal to minus 1, there is no Q elements, no display. What is the drawback of the Q? Anywhere you can't insert the elements, anywhere you can't delete the elements. Front only delete the elements, rear only insert the elements. Stack you have only one end, top will be there, one end is closed, topmost only insert element, topmost only delete. But the Q have the two ends, both directions, one is for front, another one rear. Front is nothing but deletion, rear is nothing but insertion. But anyway, stack also, Q also, both are linear data structures, linear. Stack is LIFO manner, Q is FIFO manner. What are the stack functions? Push pop display, Q function NQ DQ display. What is a stack? Real life example, pile of plates on the dining table. Q means everywhere. If you have the one way on the road, every vehicle, which vehicle first will be placed, that should be quit from the queue. Which vehicle is last place, that should be quit from the last. Tickets counter also you can example. Okay, this is the discussion about Q data structure in C language. In the next session I discussed one more data structure concept, linked list. how to store the elements in the linked list manner. In the next session I can continue. Thank you for this video.